Good afternoon. Today we're going to continue with polynomial division, and again we have with our two modes. Okay, we're going to have long division as well as synthetic division, and looking at once again for what we have with polynomial division. Let's say that if you have a ratio whereupon we have the cubic polynomial x cubed plus 4x squared plus 5 is divided by the binomial expression x plus 1. And so if we look at performing long division, right, so in the case of setting things up for what we have in accordance with long division, okay, so we're taking x plus 1, which is going to be the divisor, into the dividend, which we have to be this cubic expression. Now, in terms of setting things up, regardless of the type of polynomial division you are performing, okay, you want all the degrees of the dividend to be represented, okay, and if there are missing degree terms, we're looking at filling in the space with representation of, let's say, a void in the case of, say, the number 0. Okay, so we got x plus 1, and if we take into x cubed plus 4x squared plus 5, okay, so we have x to the third, and we have next in line we have 4x squared, and we're going from a third degree term to a second degree term. Notice we do not have an x term, a first order that is present, but we want to represent the first degree in x. Okay, so we're going to use 0x for placeholder purposes, and we want the dividend to close out with a constant. Okay, so in the setup, so you have x plus 1 into x cubed plus 4x squared plus 0x plus 5. Now, in looking at establishing the quotient, we're going to look at the first term from the divisor into the first term of the dividend. So here we're looking at dividing x into x cubed, or namely x cubed divided by x, and that is going to be at x squared. And what I'm going to do just for the earlier examples, okay, so we have x squared times all of x plus 1. Again, what I'm going to do just for the earlier cases is show you how I'm arriving at the products and how I'm applying them to the long division process. Okay, so we got x squared is multiplying all of x plus 1. So distributing, okay, we have x cubed plus x squared, and with this product I'm going to situate these terms under the like terms from the dividend. So we have x cubed under x cubed, and x squared will be lined up under 4x squared. And so looking at what we have at this stage, okay, now with long division we're going to be looking at row by row subtracting. Okay, so x cubed plus x squared will be subtracted from the polynomial dividend and lining up what we have for the like terms. Okay, so you have x cubed minus x cubed will go out, and then we have in second degree we have 4x squared minus x squared, so this will be 3x squared, and just bringing down the other terms from the dividend. So right now we got 3x squared plus 0x plus 5. And again, long division is going to be a process of doing row by row subtraction, where at each stage the object is going to be to eliminate the leading term from the dividend and anything else that spins off from it. Okay, so we had x cubed to go out. Now we're going to eliminate 3x squared. So going through the process again, so you got x into 3x squared, or 3x squared divided by x, and that is going to become 3x. Okay, so distributing 3x over all of x plus 1, So we're going to have 3x squared plus 3x. And this be carried over, so we have 3x squared plus 3x. And reapplying the subtraction. Okay. Now the first round of subtraction eliminated x cubed. Now we're going to have the elimination of 3x squared. So 3x squared minus 3x squared goes out. Then we have 0x minus 3x, or 0 minus 3x. So we have a negative 3x. And we can bring down the 5. And I can continue the long division. Now we are taking x into negative 3x. And that's going to go negative 3 times. So we have negative 3 times all of x plus 1. We'll have negative 3x minus 3. And lining up what we have now. So we got negative 3x minus 3. And once more, okay, applying subtraction. Okay, so we have negative 3x and what's going to be plus 3x. This set of terms will go out. Now we've got 5 minus negative 3, which will translate out to 5 plus 3. And so that is going to be at 8. And for what I have now, I can no longer take x into what results after the recurring stages of the long division. I could take x into x cubed, 3x squared, and also directly into negative 3x. But since 8 is a constant, and x is higher in degree in the letter x, I can no longer take x into 8. So for what we're going to have here is that the remainder is going to be at 8. And so just for the portions here in terms of identifying, okay, the function of each item. Okay, so again, the divisor is x plus 1. And what is being divided into, okay, that is going to be the dividend. Okay, which we have at x cubed plus 4x squared plus 5. Okay, and now for the quotient, like how much x plus 1 will go into the dividend without going over. And so we have the quotient, and this is going to be x squared plus 3x minus 3 and for what we have in the case of the remainder, okay, that is going to be at 8. Now, regarding this particular rational expression, okay, like in the case of Alex, I know there'll be some portions where you're looking at writing out in terms of the quotient plus the remainder over the divisor. So in expanded form, okay, so you got your quotient, you have x squared plus 3x minus 3, and with the remainder 8. Okay, so you have like the remainder over the divisor. So you have 8 over x plus 1. Okay, so that'd be like the expanded form of this, kind of like mixed number. Think of something like working with numbers. Okay, like you have 3 into 100 will go 33 times, but with a remainder of 1 left over. And So for like 100 over 3, okay, if you write as a mixed number, that would be like 33 remainder of 1 over 3, or 33 and a third. And for those of you who might be into vinyl records, especially the LPs, okay, that'd be like the RPM in this case, 33 and a third. Now, in what we have concerning polynomial division, okay, now we have in terms of what separates log from synthetic division. Okay, so you have for a polynomial, okay, so you have f of x, okay, so you have is equal to a of n, x to the n, and it's the same general polynomial expression that we looked at whenever we were looking at the end behavior of the graph of a function. Okay, so you have a polynomial of this type, and we have to be divided by a first order binomial in the form of x minus c. Okay. First of all, we have the long division setup. Is going to be, okay, whereupon you have x minus c. And we have taken into a of n, x to the n, and we have both the divisor and the dividend arranged in descending degree order. Okay, so this is going to be your long division setup. Now, in the case of the synthetic division, what's going to happen here is I'm going to have a different layout. Now, representing x minus c is going to be the 0 of x minus c. Like if x minus c is equal to 0, okay, we have the x is equal to c. Okay, so this is our long division. Now for the synthetic division setup, okay, so we got the 0 of x minus c, which we have in the letter c, and this is going to be isolated, and we have column formation, so we have c to represent x minus c, and to represent the dividend itself, we're just going to have only the coefficients. I have a of n, a of n minus 1, a of n minus 2, and you have going all the way out to the constant, which we have in general terms represented by a naught. Now, let's say that in the case of what we have with polynomial division, say we have 7 times x to the 4th and we have plus 2x squared minus 1, okay, is divided by the binomial x minus 1. Okay. And first of all, let me just mention something. Okay, now for this particular polynomial division, okay, I can use either log or synthetic division. But let me kind of mention something along the lines of separating the wheat from the chaff, okay, in terms of when you can use synthetic division and when you cannot. Okay, okay, to use synthetic division, okay, the divisor must be in the form of x minus c where x is a first degree. Okay. And just kind of giving you a case here. So you have the divisor. A divisor is presented, okay, and you have the question: can synthetic division be used directly? Now let's say we have in the first case, okay, say we have the divisor, okay, we'll say we have x minus 7, okay, so if your divisor, okay, is like in the case of x minus 7, okay, x is a first order, and so in this case, right, synthetic division can be used. Now if the divisor, say it's along the lines of, say we have x to the third plus x minus 7. Okay, well, you don't have a linear expression, and because of the third degree, okay, so the answer to that part is going to be no. And if I have something like, let's say x to the 1/4 plus 5. Okay. Again, if the x term is not a first degree, then the answer to that is no. And just another couple of cases here. If I have even something like a difference of squares, can I use synthetic division directly? And again, the answer to this is I cannot directly take it because we have the 2 as the exponent. And if I have something like x plus 10, well, the x term, there's only one x term, and this is a first order. And in that particular case, okay, I can't. So it needs to be an x expression that has only one variable term, and that variable term must be of first degree. All right, now looking at what we have, okay, for the example where we have a fourth degree polynomial divided by the binomial x minus 1. Okay, so for what we have in the case of long division, so I'm going to use LD for long division. Okay, all right, so we had the divisor. Okay, so you have at x minus 1. And we have taking into 7x to the fourth. Okay. And if you notice, okay, we don't have a third order term. So I'm going to use 0 as a placeholder. Okay, now we have 2x squared now for the next, okay, I have another missing degree term. I have a missing first order x expression, and then finally we have the dividend to close out with a constant. So just looking at what we have with taking what we have for the long division. Okay, so we have again just taking the leading terms from the divisor and the dividend. Okay, so I have x into 7x to the fourth, or 7x to the fourth divided by x. So this will leave us with 7x cubed. Again, I'm just going to do a little bit of work on the side here, at least for the initial stages, initial examples. So I got 7x cubed times all of x minus 1. So this will be 7x to the fourth minus 7x cubed. And if I take these terms and line up underneath the like terms from the dividend, so starting up, so 7x to the fourth minus 7x to the fourth will go out. And then we got 0 and what's going to be plus 7x cubed. And then we can bring the rest of the terms down, so we have plus 2x squared plus 0x minus 1. And I can continue the long division, and in this round I'm taking x into 7x cubed, which will be 7x squared times okay, so just multiplying, so we have 7x cubed minus 7x squared okay. So subtracting again, 7x cubed will go out. Now we got 2x squared minus negative 7x squared, which will change over to addition. Okay, so we're going to have 9x squared plus 0x minus 1. And I can continue. Now we have x into 9x squared, which will go 9x times and looking at distributing. Okay, so we've got 9x squared minus 9x once again, so looking at subtract, so 9x squared will go out. And we've got 0 minus negative 9x. So that's going to translate to 0 plus 9x. That can bring down the negative 1. Now we've got x into 9x will go 9 times. Okay, so we've got 9x minus 9. And we have with this remaining stage of subtracting. Okay, so 9x will go out, and then we've got negative 1, and what's going to be plus 9. And this remainder, okay, again, that is also going to be at 8. And I cannot perform division any further, for x will not go directly into 8. Alright, so we have end result. Okay, so for what we have in this particular layout, and just putting in quotient and remainder over divisor terms. Okay, so this will come out what we have with 7x cubed plus 7x squared plus 9x plus 9. And you have plus 8 all over x minus 1. Okay, so this will be the layout for what we have in the case of the line division. Now, for what we have in the case of, if I were to take what I have here and put along the lines of synthetic division, so just putting in the context of synthetic division. Okay, so I'm still taking x minus 1 into this polynomial, and I still need the 0 placeholders. And I can take synthetic division since the divisor is first order in x. So you have bisynthetic division. Okay, so you've got 1 to 0. And then with the coefficients, so we've got 7 for x to the 4th, 0 for the missing x cubed, 2 for the missing x squared, or should say 2 for the x squared, 0 for the missing first order x term. And again, we have closing out with negative 1. Okay, so we got here. Okay, now again with line division, you're looking at row by row subtracting. Now for synthetic division, you're going to be looking at column by column addition. And so you have quite a change in the technique, plus you'll be saving quite a bit of space potentially. Okay, so in terms of initiating the process with synthetic division, okay, we have the leading coefficient from the dividend is 7. Okay, which refers to 7x to the 4th. And whatever the leading coefficient is, this is going to be brought down and be multiplied by the 0 in this case, which we have at 1. And after you take the product into the next column. So 7 is brought down. 1 times 7 is 7. And this will be transported to the next column, where we're going to have 0 plus 7 is going to be another 7. Then we have 1 times 7 is 7, and this next 7 is going to be taken over to the third column and will be added to 2, whereupon 2 plus 7 is going to be 9. And then we have 1 times 9 is 9. 0 plus 9 is 9. And then we have 1 times 9 is another 9. And this time around we have negative 1 plus 9 comes out to 8. Okay. So for the last column total, okay, the remainder is going to be at 8. And for the 7799 expression, again, those are going to be digit representations of variable terms in the quotient. Notice the 7020 negative 1 was in reference to the setup for 7x to the 4th plus 2x squared minus 1. And for the 7 at the top, that referred to 7x to the 4th. But after bringing down 7, the degree of the variable represented is going to go down by 1. So this leading 7 is being in reference to the first term of the quotient, which will now be 7x cubed. Next will be 7x squared. And for the 9's that follow, this will be in reference to plus 9x. And you have plus 9. So you have this bit of history to repeat. And so in the case of synthetic division, okay, it's a different pathway, but it will arrive at the same destination, and it can be used directly as long as the divisor is first degree. All right, now in the case of taking what we have in the group of problems, okay, from page 279, now, the case of what we have with number 12. Okay, now this problem is set up in terms of long division. And I want to mention something about this as well, especially as it pertains to Alex. Okay, so you got the divisor at x plus 3. You got 3x to the 4th plus 17x cubed. We have plus 20x squared. We have minus 28x minus 48. All right. So just looking at the process. All right, so you got all the degrees in the dividend represent 4, 3, 2, 1, and the constant. And just in the leadoff, we have x into 3x to the 4th. So this will go 3x cubed times. And if I distribute, okay, so 3x cubed times x is going to be 3x to the 4th. I'll put this underneath 3x to the 4th. And 3x cubed times 3, this will be 9x cubed. Now we'll situate this underneath 17x cubed. And looking at subtracting, okay, so you have 3x to the 4th will subtract itself and cancel. Now we've got 17x cubed minus 9x cubed, so we have 8x cubed. Okay, I can bring down the rest of the terms. Okay, now we got x into 8x cubed, which will go 8x squared times, and distributing. Okay, so 8x squared times x is going to be 8x cubed. 8x squared times 3 is going to be 24x squared. Again, the long division is row by row subtracting. Okay, so in this round, 8x cubed minus 8x cubed goes out. 20x squared minus 24x squared. This will be a negative 4x squared. have minus 28x minus 48. And then we have for the next term of the quotient, okay, so that's going to be x into negative 4x squared, which would be negative 4x times, and distributing, okay, so we have negative 4x squared. Negative 4x over 3 is going to be a negative 12x. With subtracting, so we have negative 4x squared, and what's going to be plus 4x squared will go out, and we've got negative 28x and plus 12x, so this will be negative 16x. We have minus 48, and then we have x into negative 16x, so we have the last term of the quotient, which will be negative 16, and we have upon distributing, okay, so we'll have negative 16x, and negative 16 over 3 is going to be a negative 48. And subtracting once more. And what's going to happen, we have negative 16x plus 16x. That will go out, and we have negative 48, and what's going to be plus 48, and this is also going to go out. So in terms of the items, now, so you're going to have for your quotients, we have 3x cubed plus 8x squared minus 4x minus 16. Now the remainder is going to be 0. So that signals that x plus 3 goes perfectly or completely into this fourth order polynomial. Okay, so in other words, like if you had the quotient times x plus 3, that comes out to this fourth order expression. Now, for what we have regarding the ratio, and I just wanted to mention this. For what we have in terms of expressing in quotients and remainder terms, with the remainder over the divisor. Okay. Now, if this were like a handwritten quiz or assignment or test, now just the quotient alone, as far as I'm concerned, would suffice, would be completely correct, which it is. But if you have a remainder of 0 and you try to enter just the quotients into ALEKS, ALEKS might not take it. And the reason for that is that ALEKS, it wants to see the remainder over the divisor, even if the remainder is 0. So I just want to go ahead and mention this in advance. Okay, so you have, so like, it's like this isn't right answer in a traditional setting. But in the case of ALEKS, okay, you have for the quotient, and then you have to tag along and throw in the remainder 0. And we have all over x plus 3. So in case of ALEKS, it's going to be this whole package of the quotient plus the remainder over the divisor, even when the remainder is 0. All right. Now, in the case of number 16, and this is a case of polynomial division, okay, where you're looking at x squared minus 3 as the divisor. Okay. Now I'm creating a little bit of a spread here. I'll show you why in just a moment. Okay, so you have x squared minus 3 is the divisor. And the polynomial is a fifth order expression where we have x to the fifth minus 2x to the fourth. And we have plus x cubed. And we have plus. Okay, now the next term, okay, we have minus 8x, but again, we got a missing x squared term. And after this, we have minus 8x. And we have plus 18 at the end. Okay, and now with the divisor, not at x minus 3 or x plus 3, but at x squared. And it's because of the 2 here. That we cannot use synthetic division directly. Alright, now in taking what we have in the setup, now the author mentions this in her book, okay, and really it's optional. Now you definitely need 0 placeholders in the dividend, but setting up a 0 placeholder for the divisor is really optional. I'm going to throw this in anyway, just to get things aligned. So you have x squared minus 3 or 0x in the middle. X squared plus 0x minus 3. Still the same problem. Now, again, I cannot use synthetic division directly, so I'm limited right now with exclusively the use of long division. And looking at the leading terms, okay, so I have x squared into x to the fifth. So this will go x cubed times. And looking at what we have upon distributing, okay, so I have x cubed times x squared. So this will be x to the fifth. Then got x cubed times 0x. Well, it's just going to be 0 or 0x to the fourth. And x cubed times negative 3. So this will be negative 3x cubed. Okay, so x to the fifth will go out. Now nothing gets taken away from minus 2x to the fourth. So this will be the leadoff term in the next round. And we have x cubed, and what is going to be plus 3x cubed. So I have 4x cubed. I can bring down the remaining terms originating from the dividend. Okay, so to x squared and x to the fifth. Now for x squared into negative 2x to the fourth. Okay, so we have negative 2x squared. And distributing, okay, so now we have negative 2x to the fourth. Then we have 0x cubed. Negative 2x squared over negative 3, that's going to be a positive 6x squared. And subtract, so negative 2x to the fourth goes out. Now we've got 4x cubed. It's going to be the next leading term. We've got 0 minus 6x squared. We have minus x, 8x, plus 18. Okay, so for the next go round, we now have x squared into 4x cubed, which will go 4x times, and distributing, so we've got 4x cubed We have plus 0x squared. We've got 4x times negative 3, so we have a negative 12x. And subtract, so 4x cubed goes out. And now we have negative 6x squared. And negative 8x plus 12x. Okay, so that is going to be a 4x. Now we can bring down the 18. And then we have x squared into negative 6x squared. So this will go negative 6 times. And we have, looking at distributing, so we have negative 6x squared. And now we're going to have 0x. Negative 6 times negative 3 is going to be a positive 18. So we have, upon subtraction, we have negative 6x squared plus 6x squared, so those will negate each other. And we got 4x minus nothing, so that leaves us with 4x. Then we have 18 minus 18, that will go out. So in this case, all right, we're going to have a variable expression remainder. With 4x. Again, for the quotient, it's going to be this cubic polynomial expression and for what we have in sum, if I had to display the result along the lines of quotient, remainder, and divisor terms. So for the way that this is going to appear, okay, so you've got this ratio and putting in terms of quotient and remainder over divisor terms, so we have x cubed minus 2x squared plus 4x minus 6, and the remainder again is going to be 4x, and this is going to be all over x squared minus 3. So that'll be the expanded notation for what we have in quotient and remainder terms. All right, and now, yeah, in the case of long division, okay, that can get to be kind of a long exercise, okay, and quite a few needles to thread. And now for the next portion, okay, we're going to be focusing exclusively on the synthetic division part. Okay. So if we're looking at using synthetic division, to find the quotient and remainder. Okay. And say we have in the case of number 20. Okay, so we got x cubed plus 64 is divided by x plus 4. And if I take what I have here, okay, now we're going to use synthetic division. I just want to mention for the long division setup, okay, we're not using long division, but just setting up, okay, make sure we don't have any missing degree terms. So we got x plus 4. And for x cubed plus 64, so we got x to the third. And notice this is the only variable term we have in the dividend. So everything else is going to be involving 0 placeholders. So we got 0x squared, and we have plus 0x, and we finally have closing out with the number 64. And so this is your long division setup. Okay, so just creating the pathway to utilizing synthetic division. So if I have x plus 4 is equal to 0, and I have the x is equal to negative 4 as the 0, so you have bisynthetic division. So you have negative 4. And for the coefficients, so we have 1 for x cubed, 0 for the missing x squared term, 0 for the missing first order x term. And we finally have closing out with the constant value 64. Again, with synthetic division, you're looking at column by column addition. Okay, so leading coefficient, you have 1 originating from x cubed. This will be brought down. And this one is going to be representing x squared. Okay, and just completing what we have for the remaining columns. Okay, so 1 is brought down. And then we have negative 4 times 1 is negative 4. 0 plus negative 4 is minus 4. And then we have negative 4 times negative 4. So this will be positive 16. 0 plus 16 is 16. Now we have negative 4 times 16 is negative 64. And 64 plus negative 64, okay, that is going to be 0. Okay, and so here we're going to have for the remainder, the remainder is going to be at 0. And in terms of what we have for the quotient, okay, the 1, the negative 4, and the 16, again, the 1 at the top was in reference to x cubed. Bringing down, as you bring down the leading coefficient, you're also bringing down by 1 the degree in x. Okay, so this one is going to be in reference to 1x squared. Negative 4, we have minus 4x. And then we have, at the end, we have plus 16. So this is the quotient, and again we have no remainder, and so this is saying that we have complete divisibility. So like the quotient times x plus 4, or x plus 4 times x squared minus 4x plus 16. If you take the product, it's going to go exactly to x cubed plus 64. Now for 24, okay, now we're looking at the divisor, okay, at x minus 2. And we're involving, looks like, fourth order polynomial dividend. Okay, so just going to mention this case, you have x minus 2. And we have taking into, and we have x to the fourth. Minus 5x cubed. plus 2x squared minus x plus 20. Okay, and if we applied log division throughout, okay, that could take up quite a bit of space. But again, with the divisor, first order in x, I can go with the synthetic division setup. So to represent x minus 2, I can take the 0. Okay, by synthetic division. Okay, so you have the 0 of x minus 2, which we have at 2. And setting up the coefficients of the dividend. So you have 1 for x to the 4th, negative 5 for x cubed, 2 for x squared, negative 1 for the negative x term. And again, we have closing out with the constant value 20. All right. So here we have, starting out, okay, so you have 1 is in reference to x to the 4th. If I bring it down, we're going to have in the quotient this number 1 is going to be in reference to x cubed, okay, and looking at discovering the remaining coefficients. All right, so you have 2 times 1 is 2. Then we have negative 5 plus 2 is going to be negative 3. Now we have 2 times negative 3 is negative 6. And we have 2 plus negative 6 is negative 4. Now we got 2 times negative 4 is negative 8. Negative 1 plus negative 8 is negative 9. And 2 times negative 9, okay, is negative 18. And 20 and negative 18 will come out to 2. So for the quotients and the remainder, we have the value of the remainder to be at 2. And for the quotient is always going to be less in degree than the original dividend. Okay, so for what was 1x to the 4th, after 1 is brought down, this will be representing 1x cubed. Then we have minus 3x squared. Then we have negative 4x. And we have followed by negative 9. So you got this quotient, and again, you're going to have the remainder to end up with the number 2. And now, for what we have in the case of number 30. Okay. In the case of the, say, log division setup. Okay, so we got the divisor at x minus 3. And taking into the dividend, okay, which we have at 2x squared plus x minus 21. And so putting in terms of synthetic division, so we have x minus 3 is equal to 0. We have x is equal to 3. Again, we have by synthetic division. Okay, so you have 3 for the coefficients. Now we got 2 for the x squared, 1 for the x, and negative 21 for the constant. So we have in the process. So 2 is brought down. 3 times 2 is 6. 1 plus 6 is 7. 3 times 7 is 21. And we have negative 21 plus 21 is 0. So we're going to have complete divisibility here. So the remainder is going to be at 0. And it's going to turn out that the quotient is going to be exactly how many times x minus 3 will go into 2x squared plus x minus 21 And for the 2 and the 7, this will signal that how many times it will go is going to be 2x plus 7. And in the case of what we have, say for 34, this is one where you definitely would prefer synthetic division. Okay, so we've got a linear divisor. Okay, so we're back to x minus 2. And the dividend, okay, we have to be fifth order. And it's like all the places will be filled. So you got 2x to the 5th plus 13x to the 4th minus 3x cubed minus 58x squared. We have minus 20x, and we have followed by the addition of 24. And solving by synthetic division. Okay, so we got a linear divisor with x minus 2, and x is a first degree, so I can use synthetic division directly. So I have 2 to represent x minus 2. And now setting up the coefficients of the dividend. So I got 2 for the 5th degree, 13 for the 4th degree. 3rd degree I have -3. 2nd degree I have the coefficient at -58. First order in x I have the coefficient -20. And finally closing out with the constant, which we're going to have with positive 24. Okay. So just setting things up here. So we have our leading coefficient of the dividend. This will be brought down. And here we got 2 times 2 is 4. 13 plus 4 is 17. Then we have 2 times 17 is 34. -3 plus 34 is 31. 2 times 31 is going to be 62. -58 plus 62 is 4. 2 times 4 is 8. -20 plus 8. Okay, so that is going to be at -12. And 2 times -12 is -24. And 24 and -24, that is going to be at 0. Okay, so again, the last column total is going to be the remainder. So that's going to be 0. And then we have for this wide array of numbers, the 2, 17, 31. Now the leading 2, so we're shifting from 2x to the 5th to now 2x to the 4th in the quotient. And for the rest of the terms in the quotient, we got 2x to the 4th followed by 17x cubed, 31x squared, followed by plus 4x, and finally we have at minus 12. Okay. And since the remainder is 0, it would turn out that the product of x minus 2 and this 4th degree quotient would come out to this 5th order polynomial. Alright, and tell you what, just for the next few moments, say by synthetic division, see what we get for the quotient and remainder. Okay, whereupon we have x to the 4th plus 3x cubed minus 2x plus 5 is divided by the quantity of x minus 1. And also, let's see what we get whenever we have 2x cubed plus 2x is divided by the quantity of x plus 2. So for just the next few moments, let's see what we get for the quotient and the remainder from these two exercises. Okay, again, we are going to be looking into synthetic division. We just make sure that the coefficients are aligned properly. Okay, so we can set up the synthetic division properly. Okay, so if I look at envisioning what we have from the long division setup, again, the divisor in the first case is going to be x minus 1. And for the dividend, okay, so we got 3x to the fourth and we have plus 3x cubed. Okay, notice we have a missing second order term, so I'm going to need a 0 placeholder. Then we got negative 2x, and we have closing out with the number 5. Okay, and we get to synthetic division on this one. Now for 2x cubed plus 2x divided by x plus 2. So x plus 2 is the divisor. Now in terms of setting up the dividend, okay, so you have at the front we have 2x cubed, and we have a missing x squared term, so we have plus 0x squared, and then we have plus 2x. Now again, not too many problems are presented among textbooks, but for long division, synthetic division, one might wonder, okay, if the last term in the dividend is a variable expression, do I need to continue adding? And if you don't have anything that closes out with a constant, yes, you do have to fill in the remaining spaces. So in this case, we have a missing constant. So you want the last term of the dividend will be the representation of a constant. So you want all the degrees from the leading term all the way down to a constant to be covered. All right. Now, so for the first problem, okay, have putting in terms of synthetic division. Now again, we have x minus 1 as the divisor, and the corresponding 0. Then we have it at 1. Putting in terms of synthetic division, so we got 1 for x minus 1, then we have 3 for x to the fourth, 3 for the cube of x, 0 for the missing x squared term, and we have negative 2 for the missing first order x. We have closing out with the constant value 5. And looking at synthetic division. Okay, so leading coefficient 3 is 3. We bring this down. And we have 1 times 3 is 3. The product is brought over into the next column, so we now have 3 plus 3 is 6. Then we have 1 times 6 is 6. Then we have 0 plus 6 is another 6. And we have 1 times 6. We have 6, and this will be brought over. And we have negative 2 plus 6 is 4. 1 times 4 is 4. And we have the last column total, that is going to be at 9. Okay. So here, the remainder is going to be at 9. And for what we have for the quotient, okay, that's going to be in reference to 3x to the third plus 6x squared plus 6x plus 4. And for the synthetic division, with the divisor at x plus 2. So if x plus 2 is 0, then the 0 value in the synthetic division is going to be at negative 2. So setting up what we have, so got negative 2 in reference to the divisor, and then for the coefficients of the dividend, so we got 2, 0 for the missing x squared, 2 for the 2x term, and again 0 for the missing constant at the end. And the synthetic division, so leading coefficient is 2, bring that down. Negative 2 times 2 is negative 4. 0 plus negative 4 is negative 4. Negative 2 times negative 4 is 8. 2 plus 8 is 10. Negative 2 times 10 is negative 20. And 0 plus negative 20 is minus 20. So here we're going to have the remainder to be at negative 20. And for the quotients, okay, the 2, the negative 4, and the 10, okay, this will be referencing 2x squared minus 4x plus 10. Okay. And just sort of close out just a couple of theorems that will be intertwined. First of these, okay, we'll have with the remainder theorem. And it states that and this is going to be reminiscent of the determination of function values. Say if a polynomial function f of x is divided by x minus c, then the remainder will be f of c. And tied into this is going to be the factor theorem. And you're working with the remainder theorem, and you're going to have results, and this is going to be kind of like a binary sort of theorem, not as in like zeros and ones, like binary number system, but like in the case of yes and no. First of all, okay, if the remainder f of c is equal to 0, then x minus c is a factor of f of x and we have, on the other hand, that if the remainder f of c does not equal to 0, then x minus c is not a factor of f of x. So if it is, then it is, and if it's not, then it's not. Okay, and we'll be picking up with these items